In this video, we have been told to solve the integral sine of 1 divided by x, and this is divided by x to the power of 3 times dx. How can you solve such an integral? First of all, if you look at x to the power of 3, we can express it in a different way using the rules of exponents. X to the power of 3 is the same as x and then times x to the power of 2. From the rules of exponents, whenever you have, let's say, a raised to the power of n times a raised to the power of m, this will be equal to a to the power of n plus m. In simple terms, whenever you are multiplying by the same base, you add the exponents. In our case, the first x variable has a power of 1, and therefore 1 plus 2 will give us 3. So we shall write our integral as the integral of sine 1 divided by x, and this will be divided by x and then times x to the power of 2 times dx. And this can also be written as the integral of 1 divided by x times sine of 1 over x and then times 1 divided by x to the power of 2 times dx. Now at this point, what should we do next? Let's try and apply u substitution. We shall let u to be equal to 1 divided by x, and the x variable has a power of 1. If we take the variable to the top, the power will become negative. Therefore u will be equal to x to the power of negative 1. And if we differentiate this, du will be equal to the derivative of x to the power of negative 1 will be negative x raised to the power of negative 2 times dx. And whenever you have a negative exponent, you can take the variable to the bottom and the negative exponent will become positive. Therefore du will be equal to negative 1 divided by x to the power of 2 times dx. So at this point, what we shall do, we shall replace 1 over x with u. And then we shall put du in the place of 1 over x to the power of 2 times dx. However, you should note that in our integral, we don't have a negative. So what we shall do, we shall multiply this by negative 1, and in order to maintain the balance of the integral, we shall introduce a negative on the outside. A negative times a negative will give us a positive. Therefore, mathematically, we have not changed anything. And so this will become negative integral of 1 divided by x times sine 1 over x, and then times negative 1 divided by x to the power of 2 times dx. So we shall replace 1 over x with u. Also we shall replace this with u, and then we shall replace this with du. So this will become negative integral of u times sine u and then times du. And at this point, we shall solve this integral using integration by parts. We shall set a to be equal to u. And if we differentiate this, dA will be equal to du. And then we shall set dv to be equal to sine u times du. If we integrate both sides, on the left hand side we shall have v equaling to, on the right hand side you get negative cosine u. And according to the formula of integration by parts, our integral will be equal to fv minus the integral of v times dA. But since we have a negative on our integral, we shall also multiply this by negative. So this will be equal to negative into, now fv is the same as u times negative cosine u. So this will be negative u cosine u, and then minus the integral v is the same as negative cosine u, and then dA is equal to du. So this will be equal to negative into negative u cosine u, and then a negative times a negative will give us a positive. So this will be plus integral of cosine u du. This will give us negative into negative u cosine u, and then plus, when you integrate cosine you get sine, so this will be sine u, and then plus c. And if we distribute the negative, we shall have u cosine u minus sine u plus c. And if you remember, we had set u to be equal to 1 divided by x. Therefore, the integral of sine 1 divided by x and then divided by x to the power of 3 dx will be equal to 1 divided by x times cosine 1 over x, and then minus sine 1 divided by x plus c. Therefore, that's how you can solve such an integral. If you have found this video helpful, don't forget to like it and also subscribe to my channel. Thank you for watching and have a nice day.